solar eclipse is not a beautiful celestial event, it is a moving wound. That sounds wrong because every photograph you have ever seen tells a different story. The moon glides peacefully across the sun. Crowds gather, cameras click, scientists smile, the sky darkens, birds become confused. Then the light returns and everyone goes home, believing they have witnessed one of nature's most elegant spectacles. But from space, the truth is far stranger. From space, a solar eclipse does not look like the sun disappearing. It looks like darkness attacking a planet. And once you see it that way, you can never unsee it. The common misconception is simple. Most people imagine an eclipse as something happening in the sky above Earth. They imagine standing on the ground and watching the moon move between themselves and the sun. That is the human perspective, the tiny perspective, the perspective of a species trapped at the bottom of an atmosphere. But astronauts, satellites, and spacecraft reveal something completely different. The eclipse is not happening in the sky. The eclipse is happening on Earth. The real event is the shadow, a colossal shadow, a black stain racing across an entire world. Imagine looking down at Earth from hundreds of kilometers above the surface. The oceans are blue, the continents glow under sunlight. Cloud systems swirl like giant white hurricanes. Everything appears calm. Then suddenly you notice something impossible. A perfectly circular patch of darkness is moving across the planet. Not drifting, not floating, charging at thousands of kilometers per hour, like a cosmic predator hunting across the face of Earth. That dark circle is the umbra, the deepest part of the moon's shadow, and it is one of the strangest things you can ever witness in the solar system. Because shadows are not supposed to move like that. In your everyday life, shadows creep. They slide slowly across sidewalks. They stretch across fields at sunset. They never race across continents. Yet during a total solar eclipse, the moon's shadow can travel faster than the speed of sound. In some locations, it can exceed 1,700 kilometers per hour. Elsewhere, it can move even faster. Imagine standing in New York and watching a shadow reach Los Angeles in only a few hours. That is what the moon does. Every total solar eclipse becomes a planetary scale demonstration of orbital mechanics. The moon is orbiting Earth at roughly 3,700 kilometers per hour. Earth itself is rotating at about 1,670 kilometers per hour at the equator. Meanwhile, both bodies are hurtling around the sun at nearly 107,000 kilometers per hour. The result is a celestial dance so precise that a black circle only a few hundred kilometers wide can sweep across an entire planet with astonishing accuracy. And all of it depends on a coincidence so extraordinary that some scientists still describe it as one of the most remarkable accidents in nature. The moon is approximately 400 times smaller than the sun, yet the sun is approximately 400 times farther away. The two ratios almost perfectly cancel each other out. From Earth, both objects appear nearly the same size. If the moon were slightly smaller, total eclipses would not exist. If it orbited slightly farther away, total eclipses would not exist. If humanity had evolved hundreds of millions of years in the future, total eclipses might not exist either, because the moon is leaving us. Every year, it drifts away from Earth by about 3.8 centimeters, roughly the speed your fingernails grow. That sounds insignificant. It is not. Over millions of years, those tiny increments accumulate into enormous distances. Eventually, the moon will appear too small to completely cover the sun. The great eclipses will vanish forever. Future civilizations, if any exist, may never witness one. They will read about them the way we read about extinct animals. Ancient wonders. Lost phenomena, ghosts of a younger Earth. And that realization transforms every eclipse into something else. A temporary privilege, a brief chapter in planetary history. For now, however, the geometry remains perfect, and that geometry creates one of the most dramatic sights ever observed from orbit. The first astronauts who saw eclipses from space described an experience almost impossible to compare with anything on Earth. Because from orbit, you are no longer inside the shadow, you are above it. You become an observer watching an entire world interact with celestial mechanics in real time. Imagine floating inside the International Space Station, 400 kilometers above Earth. Outside the window, continents pass beneath you. The horizon curves gently. The atmosphere forms a thin, glowing shell. It looks fragile because it is. That delicate blue line contains nearly every human who has ever lived. Every war, every city, every love story, every empire, everything. And then you notice the darkness. At first, it resembles a storm, a strange circular cloud. But clouds do not behave this way. Clouds twist, clouds deform, clouds evolve. This thing remains nearly perfect, sharp, defined, purposeful. A dark disk moving over mountains, forests, deserts, and oceans, silently, relentlessly, like an ink stain spreading across a map. Only it is not spreading, it is racing. The shadow can cover hundreds of kilometers in diameter. Entire cities disappear beneath it. Millions of people enter darkness simultaneously. One moment they stand under sunlight, the next they stand beneath a black sky. And from orbit, you can watch the transition happen, not as individual human experiences, but as a planetary event. That perspective changes everything, because suddenly Earth stops looking permanent. It stops looking dominant. Instead, it looks vulnerable, a small sphere being crossed by the shadow of another small sphere. Both controlled by gravitational forces they cannot resist, neither deciding their paths, neither choosing their destinies, just obeying physics. The same physics that governs stars, galaxies, black holes, and the expansion of the universe itself. A solar eclipse is often described as alignment, but alignment sounds gentle, orderly, almost peaceful. The reality is more dramatic. What you are witnessing is a cosmic firing solution calculated by gravity over billions of years. A precision event so exact that a celestial body 3,474 kilometers wide can cast a shadow onto another body 12,742 kilometers wide and strike a specific location with astonishing accuracy. It is like throwing a coin across an ocean and landing it on a moving ship, except nature performs this feat effortlessly. Again and again, century after century, millennium after millennium. And from space, all of that complexity reveals itself at once. The shadow, the motion, the scale, the impossible precision. But what astronauts soon discovered was that the shadow itself was only the beginning, because as the darkness raced across Earth, something even stranger began happening to the planet beneath it, and the view became almost alien. On the ground, a total solar eclipse feels like the sky changing. From space, it feels like the Earth changing. That difference is enormous, because once you leave the surface behind, you stop watching the sun disappear and start watching an entire world react to the sudden theft of daylight. The first thing astronauts notice is that the shadow is alive. Not literally, but it behaves with a strange sense of purpose. The moon's umbra is not some fuzzy patch of darkness wandering across the atmosphere. It is a sharply defined region where sunlight has been completely cut off. It races over mountains, oceans, forests, cities, deserts, and cloud systems, transforming everything beneath it. Astronauts aboard the International Space Station have repeatedly photographed this shadow as a dark circular stain moving across Earth's surface. From orbit, it is one of the most dramatic sights our planet can produce. Sight turn search 1, turn search 5, turned arrow search 3. Imagine standing on a mountain and watching a thunderstorm storm covers entire states, then make it move faster than a rifle bullet. That is closer to reality. During some eclipses, the shadow sweeps across Earth at more than 2,400 kilometers per hour. If Earth were not rotating beneath it, the shadow would move even faster. Sight turn YouTube for tube turn search 2. The speed is difficult for the human mind to process. Our instincts falling rocks, not orbital mechanics, not celestial geometry, not a shadow crossing a continent at supersonic velocity. And yet, this is exactly what happens. The moon's shadow is only possible because of an extraordinary alignment. The sun is approximately 1.39 million kilometers wide. The moon is only 3,474 kilometers wide. The sun should completely dominate the sky. Instead, distance changes everything. The sun is roughly 150 million kilometers away. The moon is only about 384,400 kilometers away. The result is a cosmic illusion so precise that one object can perfectly cover the other. So this sight, search, turn, search, search, 8. It is like holding a coin at arm's length and using it to hide an entire, vastly larger, but perspective rewrites reality. From orbit, astronauts are seeing the consequence of that illusion projected onto an entire planet. The Earth begins responding immediately. Inside the path of totality, sunlight vanishes. Temperatures start dropping, winds change, the atmosphere behaves differently. The ionosphere, a layer of charged particles high above the planet, reacts to the sudden interruption of solar energy. Scientists use eclipses to study these effects because the moon creates a temporary experiment that cannot be reproduced any other way. Sight Turn Search 7. For a few brief minutes, part of Earth experiences an artificial sunset in the middle end like an ordinary sunset. Darkness arrives from above. Suddenly, violently. Imagine someone reaching into reality and turning down the brightness control of a continent. That is essentially what the moon is doing. And from space, you can actually see it happen. The darkness does not creep across the landscape, it attacks. The edge of the shadow advances relentlessly. Everything inside the circle is transformed. Everything outside remains brilliantly illuminated. One side of a cloud system can be glowing white, while the other side is swallowed by darkness. The contrast is surreal, almost computer-generated, yet it is entirely real. Astronauts often describe Earth as looking peaceful from orbit. Borders disappear, politics disappear, conflict disappears. The planet becomes a single interconnected sphere, floating in a black void. An eclipse intensifies that feeling because the shadow does not care where nations begin or end. It crosses oceans, it crosses mountain ranges, it crosses cities containing millions of people. Humanity watches from below while gravity conducts the performance above. There is something unsettling about that. A reminder that nature operates on scales far beyond human control. The Roman Empire could not stop an eclipse. The British Empire could not stop an eclipse. Modern civilization cannot stop an eclipse. Nuclear weapons cannot stop it. Artificial intelligence cannot stop it. Financial markets cannot stop it. The shadow arrives exactly when orbital mechanics says it will arrive. Not 1 second early, not 1 second late. That precision is almost frightening. For centuries, eclipses terrified civilizations because they appeared supernatural. The sun vanished. Day became night. Animals behaved strangely. Temperatures dropped. People assumed gods were angry. Today we understand the physics, yet understanding does not make the sight less powerful. If anything, it makes it more powerful, because now we know exactly how improbable it is. The moon's shadow reaching Earth is not guaranteed. In fact, the umbra barely reaches the surface at all. The shadow narrows as it extends away from the moon. By the time it arrives at Earth, the zone of complete darkness is relatively small compared with the planet itself. The path of totality is often only a narrow strip crossing the surface. Sight Turn Search 2, Turn YouTube 14. Imagine a giant spear thrown across hundreds of thousands of kilometers, the target. That is essentially what the umbra is. A narrow cone of darkness extending from the moon, and Earth just happens to rotate beneath it. From orbit, the geometry becomes obvious. You can see the shadow's shape, you can see its path, you can see the machinery of the solar system operating exactly as physics demands. No mystery, no magic, just gravity. Yet gravity itself begins to feel magical when viewed at this scale. Because gravity is invisible, you cannot see it, you cannot touch it, you cannot hear it. And yet everything in this scene is being choreographed by it. The Earth is falling around the sun, the moon is falling around the Earth, the International Space Station is falling around the Earth. Everyone involved is falling. The only difference is the direction, like circus performers on invisible wires stretching across the solar system. And the eclipse is the moment when all of those invisible motions suddenly reveal themselves. For a few minutes, the architecture of the cosmos becomes visible, not through equations, not through telescopes, but through a moving scar of darkness crossing an entire world. And astonishingly, astronauts soon discovered that seeing the shadow from low Earth orbit was only one version of the story, because much farther away, nearly 1.5 million kilometers from Earth, another spacecraft would witness something even more unsettling. From that distance, the eclipse no longer looked like a shadow crossing a planet. It looked like the moon itself was attacking the Earth. If you could travel 1.5 million kilometers away from Earth during a solar eclipse, you would witness something that does not look natural. It would look like an attack, not because anything dangerous is happening, not because the Earth is actually under threat, but because your brain would struggle to interpret what it was seeing. The spacecraft known as Discover occupies one of the strangest locations in the solar system. It sits near the Earth-Sun L1 Lagrange point, roughly 1.5 million kilometers from Earth. From there, it enjoys a continuous view of our planet, day and night, clouds and oceans, storms and continents. The entire world hangs in space like a blue marble suspended in darkness. And when a solar eclipse occurs, Discover sees something no human civilization could have imagined before the space age. It sees the moon's shadow strike Earth, not from hundreds of kilometers above, not from the International Space Station, but from far enough away that the entire planet fits comfortably inside a single frame. From that perspective, the eclipse becomes almost unsettling. A black circular scar appears on Earth's bright surface. Then it moves across oceans, across continents, across entire weather systems. The moon itself is often visible nearby, crossing the space between Earth and the sun. Suddenly, the geometry becomes obvious. You are no longer trying to understand an eclipse. You are watching it happen. The moon is physically casting a shadow onto a planet, and that shadow is moving exactly as orbital mechanics predicts for sticks. Sight turns search 6 turns search 59. From this distance, Earth appears fragile. The atmosphere becomes all ink. The oceans dominate. Human civilization disappears entirely. No cities, no borders, no nations, no evidence that billions of people are living below. Just a sphere, a lonely sphere. And across that sphere moves a dark mark, a wound of darkness. Imagine standing across a valley and watching a cloud's shadow pass over a hillside. Now enlarge the valley until it is space itself. Enlarge the hillside until it is a planet. That is what Discover witnesses, except even that analogy fails to capture the scale, because the shadow is not crossing a field, it is crossing Earth, the only home humanity has ever known. The first time many people saw images from deep space, they assumed the photographs had been digitally altered. The contrast seemed too dramatic, too perfect, too cinematic. But physics does not care about what appears believable. The moon's shadow really is that sharp. The geometry really is that precise. And from deep space, the eclipse stops looking like a local event and starts looking like a planetary phenomenon. Sight turns search 6 turns search. This perspective reveals another extraordinary fact. The shadow itself, Earth. When viewed from far away, the umbra resembles a dark coin moving across a basketball. Human beings on the ground experience it as a world-changing event. But from deep space, it becomes obvious how narrow the path of totality actually is. A relatively thin corridor of darkness. Imagine the impossible. You are standing on the surface of the moon. No atmosphere, no wind, No sound, no blue sky, no birds, no clouds, no life, only silence. A silence so complete that it stops feeling like silence and starts feeling like another physical substance. A vast, endless emptiness. Above you hangs a black sky, not a nighttime sky, a permanently black sky. The stars are hidden by the brutal glare of sunlight reflecting from the gray lunar landscape. The horizon curves sharply in every direction. The world feels small, dead, ancient, and then you look up. Earth is hanging above you. Enormous, brilliant, alive. From the moon, Earth appears roughly 4 times larger in the sky than the moon appears from Earth. The oceans glow blue. Cloud systems swirl across continents. White storms spin across entire oceans. The atmosphere forms a delicate halo around the planet's edge. Compared to the barren lunar surface, Earth looks almost supernatural, like a living jewel suspended above a graveyard. And during a solar eclipse, something astonishing happens. The Earth goes dark. Not completely, not all at once, but a black circular shadow appears on its surface. The same shadow millions of people are experiencing below. The same shadow astronauts see from orbit. Only now you are seeing it from the source. You are standing on the object creating it. That realization is difficult to process because from the moon, the eclipse is reversed. On Earth, people watch the moon block the sun. On the moon, you watch your own shadow crossing another world. It is as if you are standing beside a giant spotlight watching your silhouette sweep across a distant wall. Except the wall is Earth, and the spotlight is the sun. The scale becomes almost absurd. A shadow created by an object only 3,474 kilometers wide stretches across a planet nearly 4 times larger. Gravity has arranged an event so precise that people on one world can witness darkness while observers on another world watch the shadow arrive. 2 worlds connected by geometry. 2 worlds connected by light. 2 worlds connected by a beam of darkness. The Apollo astronauts never witnessed a total solar eclipse from the lunar surface, but they experienced something almost as extraordinary. They watched Earth hanging motionless in the lunar sky. That alone transformed their understanding of reality. Many astronauts have described the experience of seeing Earth from space as life-changing, a cognitive shift, a profound psychological event, the overview effect, the sudden realization that humanity shares a single, fragile home. Standing on the moon would amplify that feeling beyond anything experienced in low Earth orbit, because Earth would no longer feel enormous. It would feel finite, contained, vulnerable, a place that could fit behind your thumb, a place where every human achievement exists within a thin shell of atmosphere, only a tiny fraction of the planet's diameter. If Earth were the size of a basketball, the breathable atmosphere would be thinner than a layer of paint. That is the reality astronauts discover. The atmosphere feels huge from the ground. From space, it looks terrifyingly delicate, like tissue paper wrapped around a cannonball. And during an eclipse, that fragility becomes even more apparent. The shadow exposes the atmosphere's structure. Along the edge of Earth, sunlight scatters through different layers of air. The atmosphere glows, colors emerge, bands of light appear. The planet reveals details that are normally hidden. For a brief moment, the mechanics of illumination become visible. It is like watching a stage production where the audience suddenly sees the machinery behind the curtain. The illusion remains beautiful. But now you understand how it works. That understanding is one of the greatest gifts of science. Science does not destroy wonder, it deepens it. A magician's trick loses power when explained. An eclipse gains power. Because the explanation itself is astonishing. Consider the precision involved. The sun's diameter is approximately 1.39 million kilometers. The moon's diameter is only 3,474 kilometers. Yet from Earth, they appear almost identical in size. The odds of such a coincidence seem absurd, and yet humanity exists during the narrow period of cosmic history when that coincidence is true. Hundreds of millions of years ago, total eclipses looked different. Hundreds of millions of years from now, They will disappear entirely. We live during the age of eclipses, a temporary chapter in planetary history. That fact alone changes how the event feels. Every eclipse becomes a reminder that nothing lasts. Not civilizations, not continents, not oceans, not even the geometry we take for granted. The moon is slowly drifting away, the earth is slowly changing, the sun is slowly evolving. Everything is temporary. Everything. That truth becomes unavoidable when viewed from space, because space strips away human illusions. It removes the comforting sense of permanence. The mountains seem eternal until you see them from orbit. The oceans seem infinite until you see their boundaries. Nations seem important until you realize they are invisible from space. Human arguments seem enormous until you compare them to celestial timescales. An eclipse compresses those realizations into a single event. For a few minutes, the universe reminds you who is in charge. Not governments, not corporations, not ideologies, physics, gravity, time. The ancient forces that existed long before humanity appeared and will remain long after humanity is gone. And nowhere is that lesson clearer than on the moon itself, because the moon is a world shaped by violence. Its surface is covered with impact craters, ancient scars from a chaotic solar system. Every crater tells the story of collision. Every basin tells the story of destruction. The moon is not peaceful. It is a fossilized battlefield. And yet, from that battlefield, you can watch Earth's shadow drama unfold. You can watch a living world briefly enter darkness. You can watch billions of people share the same cosmic event. And suddenly, the eclipse becomes something more than astronomy. It becomes perspective. A reminder that Earth is not the center of reality, merely a participant. One world among many. One fragile sphere moving through a vast and indifferent void. But there is another perspective that is even more extraordinary, because astronauts who have witnessed eclipses from orbit describe a moment that photographs struggle to capture, a moment when the shadow is no longer the most beautiful thing in view. Because as totality arrives, something else appears, something that should be invisible, something humanity almost never gets to see, the sun itself. The greatest illusion in the solar system is that we know what the sun looks like. We don't, at least not with our own eyes. Every image you have ever carried in your mind is incomplete, a glowing yellow disk, a bright circle in the sky, a source of warmth and daylight. That is not the real sun. That is only the visible surface, the sun's mask, its outer face. The truth remains hidden behind overwhelming brightness. The human eye cannot look directly at it. Cameras struggle to capture it. The atmosphere scatters its light. Its brilliance erases its own details. Imagine trying to study a lighthouse while standing a meter from the lamp. The light itself prevents observation. That is the challenge of the sun. Its power conceals its nature. And that is why total solar eclipses are so valuable, because for a few brief minutes, the moon performs a scientific miracle. It blocks the blinding surface and reveals the monster hiding behind it. During totality, the photosphere disappears. The photosphere is the visible surface of the sun, glowing at roughly 5,500 degrees Celsius. It is the layer responsible for nearly all the sunlight reaching Earth. Normally, it overwhelms everything else. But when the moon covers it completely, something extraordinary emerges. The corona, the sun's outer atmosphere. A ghostly halo extending millions of kilometers into space. Silvery, ethereal, alien. For most of human history, the corona was visible only during total solar eclipses. People saw it and struggled to explain it. Some believed it was a celestial crown. Others thought it was a supernatural aura. Today we know what it is, and somehow the explanation is even more astonishing. The corona is plasma, superheated plasma. Its temperature reaches millions of degrees Celsius. Pause for a moment and think about that. The sun's visible surface is around 5,500 degrees Celsius, yet the corona above it can exceed 1 million degrees. In some regions, temperatures climb even higher. This is one of the great mysteries of solar physics. How can the outer atmosphere be dramatically hotter than the surface beneath it? The answer involves magnetic fields so powerful and complex that they twist, reconnect, and unleash tremendous amounts of energy into space. The sun is not a calm ball of fire, it is a magnetic monster, a constantly shifting engine of plasma and radiation, an active star engaged in perpetual violence. From Earth, that violence is mostly invisible. During totality, it becomes visible, and from space, it becomes unforgettable. Astronauts describe the corona as almost unreal. Photographs capture portions of its beauty, but photographs struggle with dynamic range. The human eye perceives far more subtle detail: streams of light, delicate structures, long tendrils extending outward, enormous magnetic loops. The sun suddenly appears alive, not metaphorically, visually. It resembles a living organism, a giant luminous creature radiating energy in every direction. The sight can be deeply unsettling, because for the first time you understand what the sun actually is: not a distant light, a star, a genuine star. The same kind of object that fills the galaxy, the same kind of object that explodes as supernovae, the same kind of object that creates planets, the same kind of object that determines whether life can exist at all. And suddenly the familiar becomes strange. The friendly daytime sun transforms into something ancient and powerful, something humanity depends upon completely. A single second of solar output releases more energy than human civilization has used throughout its entire history. Every second, every day, for billions of years. The scale borders on incomprehensible. Imagine every power plant on Earth, every nuclear reactor, every hydroelectric dam, every wind turbine, every solar panel, every source of human energy generation combined. Then multiply that output beyond imagination. You are still nowhere near the sun. And yet, Earth survives because of distance. Distance is our shield. At approximately 150 million kilometers away, the sun provides exactly enough energy to sustain life without vaporizing the oceans. Move Earth slightly closer, and the planet begins transforming into a furnace. Move it slightly farther, and global ice expands. Life exists within a narrow zone of possibility, a thin corridor between inferno and deep freeze. The eclipse reminds us of that fact, because for a few minutes, sunlight disappears. Not permanently, not dangerously, but enough to reveal how completely we depend on it. Temperatures drop, animals change behavior, the atmosphere responds, the planet notices. Earth is so thoroughly connected to solar energy that even a brief interruption produces measurable consequences. And yet, while people on the ground are staring at the darkened sun, astronauts often notice something equally extraordinary: the stars. During totality, stars become visible in daytime. Planets emerge. Venus may appear brilliantly bright. Mercury can sometimes be seen. The sky becomes a bizarre hybrid. Neither day nor night, neither sunrise nor sunset, an entirely different category of experience. Imagine seeing the stars while the horizon remains illuminated. Imagine seeing a black hole punched into the sky, surrounded by a glowing halo of plasma. That is what totality feels like. It feels wrong. Not frightening exactly, but deeply unfamiliar. The human brain has evolved beneath predictable skies: blue day, black night, bright sun, dark stars. An eclipse temporarily destroys those categories. Reality becomes confused, and from space, the effect is even more dramatic, because astronauts are already living outside normal human experience. They see 16 sunrises and sunsets every day aboard the International Space Station. They witness lightning storms from above. They watch auroras dance beneath them. They observe hurricanes spanning entire oceans. Yet even among these spectacles, eclipses stand apart. Why? Because an eclipse reveals hidden architecture. It exposes relationships that are normally invisible: the relationship between Earth and Moon, the relationship between Moon and Sun, the relationship between sunlight and life, the relationship between gravity and time. For a few minutes, the solar system becomes understandable. Not because it becomes simpler, but because its complexity becomes visible. The gears emerge from behind the clock face, and when that happens, Another realization begins to form, a realization far larger than the eclipse itself. Because the eclipse is not merely a spectacle, it is evidence. Evidence that humanity occupies an extraordinarily small position within a much larger cosmic story. A story stretching billions of years into the past and billions of years into the future. A story in which Earth is neither the beginning nor the end. The most frightening thing about a solar eclipse is not the darkness, it is the precision. Darkness is familiar. Every evening the sun sets. Every night the sky grows black. Human beings have lived with darkness for hundreds of thousands of years. There is nothing unusual about night, but there is something profoundly unsettling about a universe capable of producing an eclipse. Because an eclipse is not random, not even slightly. It is one of the most precise natural events humanity can observe. Long before satellites, long before telescopes, long before rockets, human civilizations learned to predict eclipses, not perfectly at first, but accurately enough to reveal an astonishing truth. The universe follows rules, invisible rules, reliable rules, rules that never break. The moon does not decide to create an eclipse. The earth does not request one. The sun does not participate voluntarily. All three are simply obeying physics. And physics is merciless. It does not negotiate. It does not compromise. It does not care about human expectations. The shadow arrives exactly when mathematics says it should arrive. That fact alone transformed civilization. Because once humanity discovered that eclipses could be predicted, something changed forever. For thousands of years, eclipses had been interpreted as warnings, omens, messages from gods, evidence of cosmic anger. Then astronomers began calculating them. The mystery started collapsing, the fear started fading, and a new realization emerged. The universe was understandable, not friendly, not safe, but understandable. That distinction matters, because understanding is one of humanity's greatest survival tools. The same species that once feared eclipses now launches spacecraft through the solar system. The same species that once imagined celestial monsters now lands robots on Mars. The same species that once trembled beneath darkened skies now photographs eclipses from millions of kilometers away. Knowledge changed everything. Yet knowledge also revealed something unexpected. The universe is far stranger than our myths ever imagined. Because once scientists began studying eclipses in detail, they discovered that Earth exists inside a gigantic cosmic machine, a machine of motion, a machine of gravity, a machine of time. Nothing is standing still. The moon circles Earth every 27.3 days. Earth circles the sun every 365.25 days. The sun orbits the center of the Milky Way at roughly 828,000 kilometers per hour. Meanwhile, the Milky Way itself is moving through intergalactic space. Everything is in motion. Everything. Imagine placing 3 spinning gears inside a clock. Each gear rotates at a different speed. Each gear influences the others. Now imagine those gears are thousands of kilometers wide and separated by hundreds of millions of kilometers. That is the solar system. The eclipse occurs when the gears briefly align, not because anyone designed them to, not because anyone planned it, simply because gravity created a temporary geometry, a fleeting arrangement of motion. And that word matters. Temporary. Because nothing about an eclipse is permanent. The shadow exists for minutes. The alignment lasts only briefly, then it vanishes. Gone. The solar system continues moving. The clockwork continues turning. The event becomes history. There is a lesson hidden inside that. Human beings often think in terms of permanence. Permanent cities, permanent nations, permanent institutions, permanent achievements. Space teaches a different lesson. Space teaches impermanence. The moon itself bears witness to that truth. Billions of years ago, the moon was much closer to Earth. Its presence dominated the sky. The tides were stronger. The eclipses were different. Earth itself looked different. The continents occupied different positions. Entire mountain ranges had not yet formed. Many modern species did not exist. Humanity certainly did not exist, yet the clockwork continued turning. and it will continue turning long after humanity is gone. That thought can feel uncomfortable, perhaps even frightening. But there is another way to view it. The eclipse is not evidence of insignificance. It is evidence of participation. We are part of the process. The atoms inside your body were forged in ancient stars. The calcium in your iron in your blood, the oxygen in your lungs, all of it originated in cosmic events that occurred long before Earth formed. Human beings are not separate from the universe. We are made of it. The eclipse is not something happening outside reality. It is reality. And for a brief moment, we get to witness the machinery that created us. That realization becomes even more powerful when viewed from orbit. Astronauts often describe a strange contradiction. The farther they travel from Earth, the more connected they feel to it. At first, that sounds backwards. Distance should create separation. Instead, it creates clarity. From the ground, it is easy to focus on differences: politics, languages, religions, nationalities, conflicts. From space, those divisions disappear. Earth becomes one object, one ecosystem, one fragile biosphere surrounded by lethal emptiness. The eclipse amplifies that perspective because the shadow crosses everyone. It does not discriminate: rich or poor, powerful or powerless, scientist or farmer, president or child. Everyone beneath the path of totality experiences the same cosmic event. For a few minutes, billions of years of orbital mechanics intersect with human lives, and every observer becomes part of the same story. That shared experience is surprisingly rare. Human civilization often feels fragmented, disconnected, divided. The eclipse reminds us that there are still events larger than ourselves, events that ignore borders, events that unite observation, events that force humanity to look upward together. For a brief moment, people stop focusing on each other and start focusing on the universe. That shift matters because the universe is enormous, far larger than most people truly appreciate. Our solar system feels vast. In reality, it is tiny compared to the galaxy. The galaxy feels enormous. In reality, it is one among hundreds of billions. And yet, despite those scales, an eclipse remains visible, meaningful, beautiful. The same laws governing galaxies also govern the shadow crossing Earth. The same gravity shaping black holes also guides the moon. The same physics operating in distant star systems also operates here. The eclipse is local, but its implications are universal. It is proof that the cosmos obeys a common language, a language written in mathematics and motion. And once you begin understanding that language, another realization emerges. The eclipse is not merely showing us how the solar system works. It is showing us something about ourselves, something humanity rarely confronts honestly: our fragility. The most important thing astronauts discover in space is not a new planet, not a new star, not a new scientific theory. It is how fragile Earth really is. That realization arrives quietly. No alarms, no dramatic music, no sudden revelation, just a window, a view, and a growing awareness that everything humanity has ever built exists inside an astonishingly thin layer of atmosphere. From the ground, the sky feels infinite. Look upward, and it seems to stretch forever, blue in every direction, endless, protective, permanent. But from orbit, that illusion collapses. The atmosphere becomes visible as a narrow glowing ribbon surrounding the planet, a delicate shell, a luminous skin, the famous thin blue line. And once you see it, it becomes impossible to ignore, because that thin line is all that stands between life and the void. Every breath, every ocean, every forest, every city, every child, every civilization. Protected by a layer so thin it almost seems inadequate. If Earth were reduced to the size of a classroom globe, the atmosphere containing most breathable air would be thinner than the varnish covering its surface. That is the scale we are talking about. A microscopic shield protecting an entire biosphere. And during a solar eclipse, that shield reveals itself in extraordinary ways. As the moon's shadow sweeps across Earth, sunlight interacts differently with the atmosphere. The planet begins displaying subtle changes. Colors shift, light bends, The edge of Earth glows. From orbit, astronauts can sometimes observe the atmosphere reacting to changing illumination in ways impossible to appreciate from the ground. The eclipse becomes a planetary demonstration of how deeply life depends on sunlight, because sunlight is not simply illumination, it is survival. Every ecosystem on Earth traces its energy back to the sun. Every forest, every grassland, every coral reef, every agricultural field, everything. Remove sunlight permanently, and the biosphere begins collapsing. Temperatures plummet, photosynthesis ceases, food chains fail, Earth becomes hostile to complex life. The eclipse is only temporary, yet even those brief minutes reveal how tightly connected the planet is to its star. Imagine unplugging the power source to an entire civilization, not long enough to cause catastrophe, just long enough for everyone to notice. That is what totality does. For a few minutes, Earth experiences a reminder of dependence, a reminder that our world is not self-sustaining. We exist because a star 150 million kilometers away continues burning, day after day, year after year, epoch after epoch. The sun is not merely part of the environment. It is the foundation of the environment, and from space that truth becomes impossible to ignore. Astronauts often describe Earth as looking alive, not in a poetic sense, visually alive. Clouds move, storms evolve, auroras dance, weather systems breathe across continents. The planet appears dynamic, active, changing. In contrast, most of the solar system looks dead. The moon is silent, Mercury is scorched, Mars is frozen and dry. The outer planets are hostile realms of crushing pressure and violent storms. Earth stands apart, a rare oasis in an otherwise unforgiving neighborhood. The eclipse highlights that contrast, because as darkness races across the planet, you become aware of just how extraordinary Earth truly is. The shadow moves over forests filled with life, over oceans containing countless species, over cities illuminated by human imagination. The same darkness that touches deserts touches skyscrapers. The same darkness that crosses mountains crosses schools, hospitals, homes, and farms. The eclipse becomes a moving connection between millions of individual lives, a temporary bridge built from celestial mechanics. Yet space itself remains indifferent. That is one of the most difficult lessons astronauts learn. The universe is beautiful, but beauty does not equal kindness. Space is fundamentally hostile to human life. Outside Earth's protective atmosphere, survival becomes an engineering problem. A suit fails, you die. A spacecraft loses pressure, you die. A life support system malfunctions, you die. The margin between life and death becomes brutally thin. Human beings evolved for one environment, Earth. Everywhere else requires protection. Everywhere else requires technology. Everywhere else demands acceptable risk. That phrase has accompanied every era of space exploration. Acceptable risk, because there has never been a risk-free path into the cosmos. Never. The history of exploration carries names that deserve reverence. Gus Grissom, Ed White, Roger Chaffee, the crew of Apollo 1, Vladimir Komarov, the crew of Challenger, the crew of Columbia. Men and women who accepted extraordinary danger in pursuit of knowledge, not because they were reckless, because they understood the stakes. Space exploration has always been purchased at a cost. The rockets, the engineering, the years of preparation, and sometimes, tragically, human lives. Every spacecraft flying today carries lessons written in sacrifice. Every astronaut launched into orbit travels along a path shaped by those who never returned. The eclipse serves as an unexpected reminder of that reality, because eclipses reveal scale, and scale produces humility. When viewed from orbit, Earth appears both magnificent and vulnerable. The atmosphere seems thin, human civilization seems small, the void seems endless. Yet despite those realities, people continue exploring. People continue building spacecraft. People continue reaching outward. That determination may be one of humanity's most remarkable characteristics. We know the dangers. We understand the risks. We go anyway. The same species that once feared eclipses now flies through them. The same species that once worshipped celestial events now studies them with satellites and probes. Knowledge did not eliminate wonder, it expanded it. And nowhere is that more obvious than during a total solar eclipse viewed from space. Because what begins as a moving shadow eventually becomes something larger, a reminder that humanity occupies a tiny island of life inside a vast cosmic ocean, a reminder that survival is precious, a reminder that our home is fragile, and perhaps most importantly, a reminder that every person who has ever lived shares the same thin blue line, the same atmosphere, the same world, the same shadow, the same fate. And as astronauts continue watching eclipses from orbit, another realization begins to emerge. A realization not about Earth, not about the moon, not even about the sun. A realization about time itself, billions of years in the making. A total solar eclipse may last only a few minutes, yet it is the product of billions of years. That contrast is one of the strangest aspects of the event. The experience is brief, the preparation is cosmic. Imagine spending 4 billion years arranging a meeting, calculating every movement, every orbit, every interaction, then allowing the event itself to last only 4 minutes. That is essentially what the universe does. The eclipse feels sudden because human beings experience time differently than planets do. Our lives are short. Our civilizations are temporary. Even recorded history covers only a tiny fraction of Earth's existence. Space operates on another scale entirely, a scale where mountains rise and disappear, oceans open and close, continents collide and separate, species emerge and vanish. Stars are born and die. And throughout all of it, the celestial clock continues turning. The eclipse is one visible tick of that clock, a brief alignment revealing motions that have been occurring for billions of years. Consider the moon. Today it appears familiar, comforting, permanent. But the moon was born from catastrophe. Most planetary scientists believe it formed after a collision so violent that it reshaped the young Earth itself. A Mars-sized world, often called Theia, slammed into Earth during the earliest chapter of solar system history. The impact was apocalyptic. Entire oceans of molten rock, global firestorms, material blasted into orbit. The aftermath eventually condensed into the moon. In other words, the object creating the eclipse was born from a planetary disaster, a cataclysmic event beyond anything humanity has ever experienced. The moon is not merely a companion, it is a survivor, a relic of ancient violence. Every eclipse is connected to that collision. Without it, there would be no moon. Without the moon, there would be no total solar eclipses. The event people gather to watch on a pleasant afternoon traces its origins back to one of the most destructive moments in Earth's history. Space has a strange way of connecting beauty and violence. The most beautiful nebulae often emerge from stellar death. The most spectacular planetary systems arise from collisions. The most breathtaking eclipses depend on ancient impacts. Creation and destruction are often the same story viewed from different moments in time. Astronauts understand this better than most, because space constantly forces confrontation with timescales beyond ordinary comprehension. Look at Earth from orbit, and you begin seeing time differently. Weather systems become visible as living processes. Mountain ranges reveal geological history. The movement of clouds exposes planetary circulation. You stop thinking in hours, you start thinking in systems. The eclipse encourages the same shift, because once you understand the mechanics, it becomes impossible to see it as an isolated event. You begin noticing all the processes required to make it happen. The moon's orbit, Earth's rotation, Earth's revolution around the sun, the evolution of the solar system, the formation of planets, the birth of the sun itself. Every eclipse becomes the endpoint of an enormous chain of events stretching backward through time, and it stretches forward too, because eclipses are not permanent features of Earth. They have a future, or more accurately, they have an ending. The moon is gradually moving away from Earth, approximately 3.8 centimeters every year. Again, that sounds insignificant. It isn't. Tiny changes become enormous over geological time. Millions of years accumulate. Distances grow. The geometry shifts. Eventually, the moon will appear too small to fully cover the sun. The path of totality will disappear forever. Future Earth may still experience partial eclipses, but the magnificent total eclipses that humanity celebrates today will be gone. Imagine standing in that distant future, looking up, reading about total eclipses in ancient records, knowing your ancestors once witnessed something no longer possible. A phenomenon lost not because civilization forgot it, but because orbital mechanics erased it. That future will arrive, not next year, not next century, but eventually. The clockwork never stops, and this realization transforms the eclipse into something unexpectedly precious. We often assume extraordinary things will always exist: the oceans, the stars, the moon, the familiar rhythms of nature, yet many of them are temporary. The eclipse reminds us that even cosmic events have lifespans. They are born, they evolve, they disappear, just like everything else. The universe is not a museum. It is a process, a continuous unfolding, a story still being written. And humanity happens to exist during a particularly remarkable chapter. We arrived during the age of total eclipses. We arrived during a period when the sun and moon appear almost perfectly matched in Earth's sky. We arrived at precisely the right moment to witness one of the most extraordinary optical phenomena in nature. That timing is astonishing, but it also raises a deeper question. Why does witnessing an eclipse feel so emotional? Why do people cry? Why do seasoned scientists become speechless? Why do astronauts describe profound reactions even after seeing countless wonders from orbit? The answer has little to do with astronomy and everything to do with time. The eclipse forces awareness of time, not the time shown on a clock, the deeper kind, the time measured in civilizations, in species, in planets, in stars. For a few minutes, you become aware of participating in a process vastly older than humanity. The shadow crossing Earth did not begin with us. It will not end with us. We are simply present for one brief passage, one fleeting moment in a story stretching across billions of years. That realization can feel small, but it can also feel liberating because suddenly many human concerns shrink. The arguments, the anxieties, the daily frustrations, they remain real, but they lose scale. The eclipse provides perspective. The same perspective astronauts often describe after looking back at Earth. A reminder that life is temporary, yet meaningful, brief, yet extraordinary, fragile, yet astonishingly resilient. And as the shadow continues racing across Earth, another truth emerges. Perhaps the most profound truth of all. The eclipse is not merely showing us how small we are, it is showing us something equally important: how improbable it is that we are here at all. The most astonishing thing about a solar eclipse is that it should not exist, at least not in the form we experience it. When most people learn why eclipses happen, they walk away believing they understand the event. The moon moves between Earth and the sun, the shadow falls on Earth, day becomes night. Simple. But hidden inside that explanation is one of the most extraordinary coincidences in the known universe. A coincidence so precise that if any part of it changed, total solar eclipses would vanish. The moon is approximately 400 times smaller than the sun. The sun is approximately 400 times farther away. Those numbers are not exactly identical, but they are astonishingly close. Close enough that the moon can almost perfectly cover the solar disk. Close enough that humanity can witness totality. Close enough that the corona becomes visible. Close enough that the sky darkens in daytime. Close enough that entire civilizations have been inspired, terrified, and transformed by the experience. If either number were significantly different, none of it would happen. Imagine shrinking the moon, only slightly. The sun would remain visible around the edges. Totality would disappear. The corona would remain hidden. The dramatic darkness would never arrive. Now imagine moving the moon farther away. The same result. No total eclipse, no celestial crown, no black sun hanging in the sky. The phenomenon would cease to exist. And yet somehow, here we are, living during the narrow window when the geometry works. The universe did not owe us this experience. It did not have to exist, yet it does. From space, that coincidence becomes impossible to ignore. Astronauts see the geometry directly. They see the Earth, they see the moon, they understand the distances involved. And suddenly the eclipse begins feeling less like a routine astronomical event and more like a remarkable accident of cosmic timing, because most planets do not enjoy this privilege. Imagine standing on Mars. The Martian moons, Phobos and Deimos, are tiny. They cannot create eclipses like Earth's moon. Phobos occasionally crosses the sun, but it appears far too small to cover it completely. The result resembles a dark spot sliding across the solar disk. Interesting. Scientific, but nowhere near the grandeur of totality. Travel to the giant planets and conditions become even stranger. Jupiter's large moons cast enormous shadows across the planet's cloud tops. Spectacular eclipses occur there as well. Yet no human being has ever stood beneath them. No crowd has gathered to watch. No civilization has built myths around their arrival. Earth occupies a rare position, not merely because eclipses occur,